All right, let's get right into it. If you're a safety professional, you know the drill. Preventing musculoskeletal disorders is a huge part of the job. Well, today, we're looking at something pretty groundbreaking, a system that uses deep learning to totally automate the Ovako working posture analysis system. You know it as OWAS. And look, this isn't some far-off theory. This is about making your compliance audits way faster, much more accurate, and just massively scalable. So let's break down how this thing actually works and what it could mean for your day-to-day.
So here's what we're going to cover. First, we'll talk about the real challenges with manual audits, the stuff you deal with all the time. Then, we'll get to the good part, the automated solution. We're going to peek under the hood to see how the AI sees risk, walk through how it gets from a video to an actual OWAS score, and then we'll wrap up by looking at what this all means for the future of compliance. Sound good? Let's go.
Okay, so let's start with what we all know. The goal is simple, right? Prevent those work-related musculoskeletal disorders. And for that, we have tools like OWAS. I mean, it's pretty much the gold standard. But, and this is a big but, we all know that the traditional way we do these audits, it has some pretty serious drawbacks.
And that brings me to this question, and I want you to really think about it. Your current posture assessments, how scalable are they really? And how accurate? I mean, when you're out there with a clipboard, are you truly getting the full picture? How confident can you be in that data when you're only watching for a few minutes or just sampling a handful of workers?
It's tough. And this right here really lays it all out. On the one hand, you have the traditional method, direct observation, which means you're stuck with these tiny sample sizes. And trying to scale that? Forget about it. It's just not practical. But on the other hand, what we really need in today's world is continuous monitoring. We need comprehensive data, and we need it to be super accurate, even at a massive scale. That's the gap, right? That's the problem we're trying to solve.
So the big question is, how do we bridge that gap? Well, this is where things get really interesting. We're moving from the problem to the solution now. And that solution is a pretty slick, state-of-the-art deep learning system built from the ground up to tackle exactly those issues, accuracy and scalability.
And what this system promises is honestly a total shift in how we approach safety audits. Think about it. We're moving away from just doing random spot checks, which are basically just snapshots in time, and moving toward a model of constant automated analysis. This gives you a complete, trustworthy data set, like watching the whole movie instead of just seeing a single photo.
Okay, I know what you might be thinking. How on earth does a computer see, risk, or understand a worker's posture? It sounds super complicated, right? But the cool thing is, it's all built on a concept that's actually pretty easy to grasp. It's called human pose estimation. Let's dive into that.
So, what is human pose estimation? In the simplest terms, it's an AI technique that can look at an image or a video and pinpoint a person's key body points. Like their joints and limbs. Think shoulders, elbows, hips, knees. It's basically creating a digital skeleton or a high-tech stick figure in real time. And that right there is the crucial first step to analyzing posture automatically.
And you should know, this AI isn't starting from zero. It's built on a really powerful foundation, a deep learning architecture called ResNet 18. It's been trained on these huge datasets called COCO, which have millions of images, so it already has a PhD in recognizing people in all sorts of situations. Then, through something called transfer learning, which is kind of like taking an expert and giving them specialized training for a new job, it gets fine-tuned just for workplace settings. That's what makes it so incredibly accurate.
All right, so the AI can see the key points on a person's body. That's cool. But how do we get from a bunch of digital dots to the actual OWAS score you need for your reports? This is where the magic happens. It's a really clear four-step process that turns all that visual data into a real, actionable risk score.
And here is that workflow, step by step. First, the system just watches the video of a worker doing their job. Simple enough. Second, that pose estimation AI kicks in and identifies all those key body points we talked about. Now here's the really clever part, step 3. The system plays connect the dots. It forms vectors, basically just lines between those points. So a line from the shoulder to the elbow, another from the hip to the knee, and so on. By measuring the angles between these lines, it can perfectly calculate the posture. And finally, step 4. It takes those angles and translates them directly into the OWAS risk levels you already know and use. The entire process, totally automated.
Okay, let's bring this all back to reality. What does all this tech actually mean for you? For the safety officers who are on the ground day in and day out? What does it mean for the future of how we handle compliance?
I think this quote from the research just hits the nail on the head. It says the approach,
promises unprecedented accuracy and scalability, potentially revolutionizing compliance. Listen to those words. We're not talking about a small tweak here. This is a potential revolution in how we do our jobs, making them way more data-driven and ultimately way more effective.
So what are the big wins here? Well, they're pretty clear. First, speed. The analysis is basically instant. Second, scalability. You can now analyze hours of footage across whole teams, not just one person for a few minutes. And third, accuracy. The AI is objective. It doesn't get tired. It doesn't have a bad day. It removes that human variability, giving you consistent data every single time.
All right, so if you take away just a few key things today, let it be these. This tech smashes through the old limits of manual observation. It automates the entire OWAS process from seeing the action to giving you the score. It delivers data that's fast, scalable, and incredibly accurate. Bottom line, this is a seriously powerful new tool for your safety toolkit.
And that kind of leaves us with a really exciting question to think about, doesn't it? We've just seen how AI can completely change the game for posture analysis. So what's next on the list? What other critical safety metric, something we've always thought was just too hard to automate, might now be possible?